Let's talk about the absolute ultimate crossroads for tech professionals right now. Have you found yourself wondering if you should stick to the tried and true, traditional software engineering path, or completely pivot to this wild new frontier of AI engineering? I mean, the tech landscape is literally shifting beneath our feet, and making the right choice today, that's going to define your trajectory for the next decade.
So, welcome to this explainer. I'm super excited you're tuning in, because today we're going to totally demystify these two career tracks. We're cutting straight through the hype. We'll be using real market data, actual tech stacks, and day-to-day workflow breakdowns to figure out exactly what separates a software engineer from an AI engineer in 2026.
Okay, let's dive into our roadmap real quick. We're looking at 1. Traditional software engineering. 2. The rise of AI engineering. 3. Comparing skills and tools. 4. Salaries and the AI premium. And finally, 5. Choosing your career path. Let's get into it.
All right, starting with Section 1, Traditional Software Engineering, the baseline.
So, traditional software engineering. This is our baseline, right? It's a highly specialized discipline built on systematic approaches. These are the folks applying core engineering and computer science principles to design, build, test, and maintain basically all the apps we rely on every single day. They manage the whole development lifecycle. Whether they're using Agile or DevOps, the mission is always the same. Create efficient, reliable, high-quality software and make sure it scales beautifully and ships on time.
And this field is usually broken down into specialized roles. You've got your front-end engineers building the UI and UX, the stuff we actually see and click on, using frameworks like React or Angular. Then, back-end engineers are in the background handling all the invisible server logic, APIs, and databases. Full-stack engineers? They bridge both worlds. Mobile engineers handle the iOS or Android ecosystems, and infrastructure engineers build the underlying systems, keeping the whole shebang running smoothly. Bottom line, it's a massive, varied, and super established field.
Moving on to Section 2, the rise of AI engineering, the new frontier.
Now, what's really interesting here is the title, AI Engineer. I know, it kind of sounds like something straight out of a sci-fi movie, but let's demystify this. AI engineers are not lab researchers staring at whiteboards of theoretical math. Actually, scratch that. They're the builders. They take a data scientist's model and bridge that massive gap between a cute demo that works on a laptop and a rock-solid production-ready system that handles 10,000 concurrent users at 2 a.m. They're doing the heavy lifting of integrating intelligence into working apps, managing the infrastructure, and handling real-world deployment.
And a truly fascinating part of this new frontier is the birth of entirely new disciplines. Take context engineering, for example. In 2026, with AI agents spitting out thousands of lines of code in seconds, the bottleneck isn't typing on a keyboard anymore. No way. The scarce resources are human attention and the model's actual context window. So AI engineers have to master managing these context windows to squeeze every drop of performance and reliability out of stateless, large language models. It's a complete paradigm shift in how we think about building software.
Which brings us to Section 3, Comparing Skills and Tools, the head-to-head.
Let's look at the actual tools. For the traditional software engineering stack, you're heavily focused on interfaces and relational databases. Think HTML, CSS, JavaScript, React, SQL. It's all about structured logic and crafting that user experience. But then, on the AI engineering side, it's a totally different ballgame. The workflow revolves around Python, ML frameworks like PyTorch, orchestration tools like LangChain, vector databases like Pinecone, and MLOps platforms like Docker. The whole toolkit is custom-built specifically for deploying and scaling stateless models.
But here's the thing. Despite all this incredibly advanced tooling across both stacks, there is one skill absolutely no tool can replace: human judgment. Knowing exactly which metric you can actually trust, deciding when a model is truly ready to ship, or just sensing when the numbers look fine on paper but something in the system feels off. That is the real differentiator. Plus, let's not forget soft skills. Clear communication, sharp problem-solving, and cross-functional teamwork are absolutely crucial, because you're almost never building these complex systems alone.
Let's talk money in Section 4, Salaries and the AI premium, the market reality.
So, what does this all mean for your wallet? Let's anchor ourselves with a solid baseline. According to the Bureau of Labor Statistics data, the median national wage for traditional software developers sits at roughly $133,080. That is a very healthy baseline, representing a super stable and highly sought-after career path.
However, when we zoom in on mid-career engineers in 2026, the market data shows the median total compensation is actually closer to $190,000.
Why the massive jump? Well, in tech, your base salary is really only part of the story, right? Once you factor in annual bonuses and restricted stock units, or RSUs, that total comp compounds significantly. But here is where the data gets absolutely staggering. Research shows a massive 58% wage premium for roles that are explicitly AI-focused compared to similar roles without AI. Let that sink in. And it gets better. Workers who show fluency in multiple AI tools can command up to a 43% premium, even within their own company's existing compensation bands. Employers are literally willing to pay top dollar for engineers who act as a force multiplier for their teams.
And this intense competition for talent? It's a total global phenomenon. In the US, median AI engineer salaries easily cross $138,000, with top-tier offers from tech giants blasting past $300,000. Over in the UK, AI-related developer salaries are crossing the six-figure mark, hitting over £100,000. Germany is seeing medians around 72,000 euros. And in India, while the local cost of living adjusts the USD equivalent, the median is sitting around 1.14 million rupees, with top earners making way more. These lucrative opportunities are popping up everywhere.
All right, wrapping things up with Section 5, choosing your career path, actionable advice.
If you're just starting out or looking to pivot, here are the exact steps you need. Step 1, build your core fundamentals. You need a rock-solid grasp of programming languages like Python or Java and a deep understanding of system architecture. Step 2, choose a specialization. Do you want to master web frameworks like React or dive headfirst into ML models and MLOps? And step 3, honestly the most important one, gain real-world experience. In the age of AI, getting your hands dirty with real projects, internships, or open-source contributions often outweighs a traditional degree, for sure.
I want to leave you with a question to chew on. As you look toward 2026 and beyond, ask yourself, are you a builder of interfaces? Someone who wants to craft those seamless digital experiences that people interact with every day? Or are you an orchestrator of intelligence? Someone who wants to bridge that complex gap between raw AI models and reliable reality? There's no wrong answer here, just the path that aligns with what you love doing.
Whichever path you choose, the future of tech is being written right now, and you're the one holding the pen. If you enjoyed this video, subscribe to ThinkCast for more AI and tech content. Listen to the full ThinkCast podcast on Spotify. Thanks for watching.